I'm Anil Kumar, and in this particular video we will try to understand the relation of domain in composite functions. So let us consider a composite function which is formed between the two. So f is a function which is composed with another function g of x to give us a composite function. In that case, what really happens is operation g of x is performed first. So the function, we have set of inputs here, and these set of inputs are operated by the function g of x, and we get respective output. So from here we apply g of x. So all these inputs which were there, they can be processed, and we get g of x, the output of this particular function. So in this particular case, as you can see, first set here is domain of g of x, and this one is range of g of x. Now, out of all these outputs of g of x, those which qualify for being composed with the function f of x, only those outputs are processed. Only those. So these outputs which are suitable as an input for f of x are processed, and these outputs are performed with the second operation, and then what we get is f of g of x. You get the idea. So on this, the second operation is performed, and what you get here is f of g of x. Do you get the idea? So that is how the composed functions work. So in fact, what you can have normally is that there will be only few inputs, right? For example, this is a set of inputs which will lead to this combination, which is common. The outputs which are good enough to be processed by f, which do not impose any restrictions on f, these will further be processed to give you f of x. Individually, as you will see, the function g of x can be performed on a larger group of inputs, giving you a larger output range. Similarly, f of x could be performed on a larger group, giving you output which will range with a larger range. For example, could have a bigger range. Do you understand? But when we talk about f of g of x, then what we are looking for are the inputs to g of x which can give us the outputs which are relevant inputs for f of x, right? So we get our definition here. It says the domain of f of g of x is the set of all numbers x in the domain of g such that g of x is in the domain of f, right? So I hope with this you can understand what we're trying to say. Let me take an example, right? Let me take a simple example to deal with this situation. Let us say that f of x is equals to 1 over x minus 2, and let us say that g of x is equals to square root of x. Okay, now in that case we know that domain of f of x does not include 2, and in this case all the values of x should be greater than or equal to 0, right? So what we have here is that g of x can operate on set of inputs. These are the set of inputs on which g of x operates, and results into set of outputs. Now out of these outputs, only those which qualify for f of x will now be processed to give you an output, right? So not all, correct? Not all. So that is what we're trying to say. So of course, when we talk about domain of f of g of x, then first restrictions come from the domain of g of x itself. So we say domain in this case is equals to x belongs to real numbers, and first set of output is that x is greater than equal to 0, because to give this kind of an output by the operation of g of x, x has to be greater than equal to 0. Now all the outputs of g of x may not work since f of x has a restriction. So the output of g of x, which will give you 2 as a result, cannot be considered as an input to f of x. Correct? So we have a restriction here that range of g of x should not be equal to positive 2. Do you get the idea? So the range here should not be equal to positive 2. If the range is positive 2, for example, in this particular case, 4 square root is positive 2. Now this cannot be processed by f of x, right? So the common outputs which can be processed are here, which will result into the composite function f of g of x. Do you understand? So that's the whole idea. So from the domain of g of x, we'll have to also exclude that x is not equal to 4, since 4 gives us an output which is a restriction to the function f of x. So the function will be performed only on those outputs of g of x which are valid or suitable for f of x, right? So that is a subset of range of g of x. In our example, range of g of x minus 2 will form valid input for f of g of x, right? So we will say that the domain for the function f of g of x will exclude 4 from the domain of g. Do you get the idea? From the domain of g, we have to take away 4. Since 4 will give us 2 and 2 will make f of x 0. So that is how you can understand the domain of a composite function. So let's get back to the definition now. It says the domain of f of x, f of g of x is the set of all numbers x in the domain of g such that g of x is in the domain of f, so that g of x is in the domain of f, right? So the one number which gave us 2 should be excluded, and that is how we find domain of the composite function, right? So first restriction comes from the inside function, and the next restriction comes from those inputs which will result into an output not valid for the outside function. I hope that makes things clear. Thank you and all the best.